Hello, hi. In this video, I'm going to solve another A-level physics exam question. So here is the question 8, that is the rectangle object. There are four objects A, B, C, D, and length of each object is 2 centimeter, and the height of every object is 1 centimeter. Which one of the object is in equilibrium? We have to find the which object is in equilibrium. So in order to find the object equilibrium, we use the conditions of equilibrium. Here we discuss one by one. For example, object A, if we talk about the object A, for this object A, we know that although you can see that upward forces or upward force is 10 Newton, sum of all forces along y-axis is equal to I mean, you can see that total force on the upward side is 10 Newton, and similarly the force that is acting downward are 4 Newton and 6 Newton. So downward force are minus 6 Newton and minus 4 Newton. So it means we get 10 minus 10, which get 0. So it means sum of all forces along y-axis is equal to 0. So although it satisfies first condition, I mean this is the first condition. First condition is that the sum of all forces must be equal to 0, mean the horizontal forces as well as the vertical forces. So although it satisfies the sum of forces equal to 0, but you know that the line of action of force are different, because there is another condition that sum of all moments must be equal to 0. But this does not satisfy this condition, because we know that the line of action of each force is different. Okay, so so these two forces can rotate this object. Okay, and we can see that when these two forces rotate this object, so this will not be in equilibrium. So this condition is A is the wrong option. Okay, because it does not satisfy the second condition of equilibrium, because the line of action of force are different. If we take any moment about, for example, 10 Newton point, so it will it will rotate towards the clockwise. Okay, so when it will rotate, so it means there is no more equilibrium. So for the in case of B, as we discussed that, for example, in case of B, we discuss the resultant force. We add these forces. For example, there is a 2 Newton force is acting upward, 4 Newton is acting along this side, and the resultant is 4.5 acting along this side. So if we as we know that this last vector combined with the first vector, so the resultant vector is exactly opposite to third force, mean that sum of these two forces and this resultant is opposite, so it means they will cancel, and ultimately sum of all forces mean the resultant forces must be equal to in this case. So first condition is satisfied in this case, but the second card, if we talk about the second condition, so if as we can see that the line of action of force are combining to a single point, it means these three forces are acting on a same point. Okay, are acting on the same point. If the line of action of point are the same, it means if line of action are the same, so the sum of torque must be equal to 0. So this option is the correct option. This option is the correct. Similarly, we talk about the C option C. We see that all all the forces acting on the same point, but we can see that if we find the resultant, for example, if we have the 2 Newton force, 4 Newton, so sum of these two is, that is this resultant of this is along this direction. So our third force, that is 4.5 Newton, is also acting along this direction. 4.5 Newton. So it means R and this 4.5, they add these two forces, and we get it means our resultant must be greater than that. I mean, if we add these two and we get the resultant, that is equal to 2 square plus 4 square, we get 4 plus 16, it is 20 under root, that is exactly equal to 4 point something. Okay, I say 4.5. So this is R is also 4.5, this third force is also 4.5, so our resultant will be equal to 4.5 plus 4.5, it will be around 9 Newton. Okay, so it's not equal to 0. So it means this option is the wrong. C option is also wrong, because uh, resultant is not 0, so our this does not satisfy the first condition of equilibrium. So if we talk about this D option, we come to know if we add these two forces 5.7 Newton and this 5.7, if we add by head to tail rule, the tail rule, so this is also 5.7 Newton. So our resultant must be in this direction. Resultant of these two forces in this direction, and if we see this 4 Newton force that is also acting in this direction, so it means if they are the same direction, so 4 Newton and this resultant are added, so it means our resultant does not make the 0. It can't be make the 0 because they are in the same direction. So this does not satisfy the first condition of equilibrium. So this body is not in equilibrium. So our answer is the B option, because it satisfies first condition as well as satisfy the second condition. I hope it is clear. Thank you.